Pan and Atlas are two of Saturn's closest moons and therefore are very exciting celestial bodies. If Pan's orbital radius, that is the distance from the center of Pan, the moon, to the center of Saturn, that's the orbital radius, is 1.34 times 10 to the 5 kilometers, and its period is 0.576 days. What is the orbital radius, that's the distance from one object to the other, of Atlas, whose period is 0.601 days? Once you're done with that, see about this next guy. Using the above information, calculate how far away the moon is from the Earth. Okay, where, of course, we know how long it takes the moon to go around the Earth. Something that you should think about before you jump right in is this ratio business. Because it's a ratio, you don't have to worry about getting it in terms of special units. You don't have to convert period into seconds. If you want to keep it in days, you keep it in days. If you wanted to change it into hours, that's okay too, because all this conversion business will just end up canceling out. So try it. Have fun. So if we list out the data for Atlas and for Pan, and by the way, we don't have to keep them as subscripts A and B. We can call them whatever we want. I'm saying subscript A for Atlas and P for Pan. Anyhow, we have the period for A, that's Atlas, 0.601 days. We're looking for the orbital radius of Atlas. The orbital period for Pan is 0.576 days, and the orbital radius for Pan is 1.34 times 10 to the 5 kilometers. Now, let's talk about units for just a moment. As we can see, this is in days, as is this in days. As we mentioned just a moment ago, it doesn't really matter what the units are, because this is a ratio. They will end up canceling each other out. These units are in kilometers, so that means whatever I end up getting here, whatever number will come up as the orbital radius for Atlas, that will also be in kilometers. So let's go ahead and write up the equation. This equation here, which is the same as from the previous slide. So I have TA squared divided by T, and I'm going to say P for Pan squared, equals RA cubed divided by RP for Pan cubed. Now, what is it that I'm looking for? If you recall, we're looking for orbital radius of Atlas. So let's solve for this guy. Easy enough to do. I just need to take this guy and move him up here. So I'm going to have orbital radius for Atlas cubed equals orbital radius for Pan cubed times a fraction of TA squared over TP squared. And then I have to take the cube root. If I take the cube root of this guy, and then I take the cube root of this guy, I should just be able to plug in numbers. Now, as a simple trick, you can factor out this part here. I don't know if it's technically called factoring. Anyhow, you can get RA, we've already taken the cube root of RA cubed, so it's now just RA, equals RP, and then there's the cube root of TA squared over TP squared. So that just makes it a little bit easier, a little less number crunching, but you can do it either way. We are going to need to do this in our calculators because I don't know of anyone that could reasonably do this in their heads. But if we list out the information, we're going to have, actually let me scooch it over just a tad. we're going to have, and I'll start it in blue. We're going to have radius of Pan, which was 1.34 times 10 to the 5, and that was in kilometers. Okay, which means our radius for Atlas is also going to be in kilometers. And then times the cube root of, and we have TA squared, so that's going to be 0.601 days. That is going to be squared. Divided by, this is TP squared, 0.576 days. And that is squared. And notice what happens. Days end up canceling out. That's why it doesn't really matter what units you got here as long as you are consistent. So let's go ahead and tap that into the calculator. And what do we get? I get 1.38 times 10 to the 5 kilometers. 1.38 times 10 to the 5, that's a 5, kilometers is my orbital radius for Atlas. That's what I was looking for. And as we mentioned before, it is in terms of kilometers. Now, what is this other part over here? Using this information, calculate how far from the moon the Earth is going to be, how far away the Earth is from the moon. Well, you say, what information do I know? Well, I do know that the period for the moon is about 27 days. It's not exactly that, but we'll just go with that for right now. But then that's all, right? What other information am I supposed to have? Well, the orbital radius for the moon is some unknown value. That's what I'm looking for. So you say, oh, great, use the information for Atlas or Pan, right? No, absolutely not, because this ratio here, this one outlined in black and now also circled in green, this only works if it's the same two, or if there's two satellite objects orbiting the same third object. In this case, Pan and Atlas are both orbiting Saturn. If we were talking about Earth and Mars, they would both be orbiting the Sun. But in this case, we're trying to say, hey, let's figure out about the Earth and the Moon. Those Pan and Atlas are not orbiting the Moon. Our Moon does not orbit Saturn, so it doesn't work out. It's not possible to get this information from here. Okay, so how did I write that on my sheet? Okay, so there's all my some number crunching. It says this cannot be done as the three moons do not all orbit the same object. Physics tried to trick you, but you saw through it. Oh yeah.